Hey guys, so today we're going to continue with similar triangles on a line, and today we're going to be working exclusively with y equals mx plus b. So, just to recap, similar triangles can be found along a straight line. Finding the slope is like finding the coordinates of three vertices of a right triangle. So again, if I had this graph and I had this line, just finding my slope, rising and running, rising and running, rising and running, just like a stairwell, is going to end up giving me similar triangles if I were to find a large point and then find a smaller one. So that's pretty much what we're going to be doing today. So let's move into our steps. Okay, our steps to finding similar triangles. The first step is to find two clear points on the line that you've either graphed or that's been provided for you. The second is to determine a third point that would make it a right triangle. And again, if I just had this line, and let's say I picked these 2 points. Well, I want it to be a right triangle, so I know it's going to fall where the vertex of a right triangle would be. The third step is to repeat that process to find a second triangle. So again, you'll find 2 clear points. You'll find a third point that'll make it a right triangle. And then you're going to find the rise and the run, or the slope, for both triangles and compare. And if they end up having the same slope that reduces down, then they will be similar. All right, let's move into an example. All right, let's look at this line. Now, I see immediately that this line is obviously a straight one. And that means that there are going to be similar triangles all along this line. I see that it's going down, so I know that any slopes that I'm comparing would be negative. So my first step is to identify 2 clear points on the graph. Well, this has already been done for me. I have one here at -2 and 5, and one at 0, 3. Now, I need to find a third point that would make this a right triangle. Well, I know that a right triangle, the vertex kind of looks like a loser sign. So I'm going to go to 0, -2, and that's going to be my point that's going to make this a right triangle. Now, that's my first triangle that I'm going to plot on this graph. I need to find another one. And all I have to do again is find 2 clear points on the graph. Well, let's just go right back to 3, 0, and we'll use that as our first point for our next triangle, and then I just have to find a second clear point. Boom. There's one here at 5, -2. Now, in order to find my third point that would make this a right triangle, again, I want it to look like the loser sign. I want the vertex to look like the loser sign. So I'm going to go to 3, -2. And you'll see this gives me a complete right triangle. Now, in order to determine if these slopes, or if these triangles are similar, their proportions have to be the same. And the way I figure that out is figuring out the slope of the hypotenuse of these triangles. So how do I get from this point to this point? Well, this is just really simple rise over run. So since this line is going down, I know that my rise is going to be negative because I'm going to go down first. So let's see. Again, I'm finding the rise and the run between these 2 points. Let's do our rise first. I rise, or I fall, 1, 2, 3, 4, 5. Let's see how many times I run. 1, 2, 3, 4, 5. So for this first triangle, my slope here is just going to be -1. Let's see if that's true for the second triangle. If it's true for the second triangle, then these triangles are going to be similar. All right, so again, I'm finding the slope between the 2 points of the hypotenuse. So let's see how many times I rise. 1, 2. So I'm at -2 because I went down 2. And then to the right 2. 1, 2. So I ran 2. -2 divided by 2 is going to divide down to -1. Since both of these have the same slope, these triangles are going to be similar. And again, I could do this all day long with finding clear points on the graph and creating triangles. Boom, there's another one. There's another one right there. And you could go up all along this line forever and ever. All right, this is a pretty simple lesson, so I think we should just do a ton of practice today. So let's go ahead and get to it.